For some low-dimensional matrices, there are some quick tests that you can often do to recognize some very commonly seen singular matrices without trying to reduce those matrices to reduced echelon form. The first type of such matrices are the ones that have all the row sums or all the column sums equal to 0. For example, this matrix A has the first row, all the entries adding up to 0, all the entries in the second row add up to 0, and all the entries in the third row add up to 0. And this matrix B has all the entries in the first column adding up to 0, all the entries in the second column add up to 0, and all the entries in the third column add up to 0. Let me first explain why B is singular. I can first add the first row of B to its second row, which is an elementary row operation, and B is equivalent to this matrix. I can then use another elementary row operation, adding the second row to the third row, and now the updated third row is all zeros. And as we've explained in a related video, this matrix is singular because it has a row that's entirely 0. And since B is row equivalent to a singular matrix, B is also singular. Therefore, square matrices whose column sums are all 0 are singular. And if there's a square matrix whose row sums are all 0 for each row, then the transpose of A belongs to this category. Therefore, transpose of A is singular, and therefore A is singular.